Hi friends, welcome to our channel. So in the yesterday class we have discussed regarding the linear programming problems graphical method. So here I have written 9 questions. So if you practice these 9 questions, it is very easy to solve the linear programming problems a graphical method. So in the previous class, see the question is like this: solve the following linear programming problems using graphical method. See, using graphical method is one of the important point here. So you listen the problem. First problem: maximize z is equals to 12x1 plus 16x2 subject to constraints 10x1 plus 20x2 less than or equal to 120, 8x1 plus 8x2 less than or equal to 80, then non-negativity x1 and x2 greater than or equal to 0. So this problem we solved and we kept in our YouTube channel. So you see in the iCard also. So in the iCard you are going to see this problem, what we solved and which procedure we followed. So first what we have to do, so we have to focus on this question properly. Maximize z is equals to 12x1 plus 16x2. This is the objective function and this is the subject to constraints. Two constraints are given. Okay, based on these two constraints, we are going to draw a graph. Okay, with the help of that graph, we are going to find out the corner points. So first, what we have to do? The first step is here. This unequation value should be converted into equation by removing this less than or equal to sign in maximization method and greater than or equal to sign in minimization method, and simply we have to put here is equals to symbol. Okay, that is the first method. Then next one is here, we need to find out all the corner points, or we need to find out the points here. Then next one is second, step number 2 is here, the representation of a graph. After completion of graph, we are going to get the corner points. That corner point should be kept in the step number 3, that is the computation of the objective function. So in the objective function, we are going to know the maximum value. So these are the, and so listen here, this problem we solved already and it is there in our YouTube channel. So here you observe carefully. See second problem. See how many problems are there? Once again, 1, 2, 3, 4, 5, 6, 7, 8. 8 problems are there. My dear students, practice these 8 problems. Then you are going to become a master in this topic. Okay. See, maximize z is equals to 18x1 plus 16x2 subject to constraints 15x1 plus 25x2 less than or equal to 375, 24x1 plus 11x2 less than or equal to 264. Two constraints are given here. Non-negativity x1 greater than or equal to 0, x2 greater than or equal to 0. This is the second problem. So you practice this problem. So before you are going to practice this problem, please watch this problem answer first. Then you are going to understand completely. Then it is very easy to solve this problem. Then third problem is here. Maximize z is equal to 2x plus 5y. This is the objective function. Then subject to constant, two conditions are got as a two constants are given here. X plus 2y less than or equal to 16 and 5x plus 3y less than or equal to 45. Then non-negativity x comma y greater than or equal to 0. This is the problem number 3. Then problem number 4 here. Maximize z is equals to 8x1 plus 55x2 subject to constraints here 4x1 plus 2x2 less than or equal to 40. Constraint number 1. Then second constraint here 2x1 plus 4x2 less than or equal to 32. Then non-negativity x1 comma x2 greater than or equal to 0. This is the problem number 4. The same procedure, same method you can follow. Then next one is here problem number 5. Maximize z is equal to 250x plus 75y. Objective function this one. Then subject to constraints here 5x plus y less than or equal to 100. Then x plus y less than or equal to 60. Then non-negativity is here x greater than equal to 0 and y greater than equal to 0. So this is a problem number 5. So this problem also for your practice purpose only. The next one here, the problem number 6 here, you observe carefully. This is a little bit different when comparing with the previous problems here. See, maximize z is equals to 100x1 plus 60x2 subject to constraints 5x1 plus 10x2 less than or equal to 50 and 8x1 plus 2x2 less than or equal to 16. See, two constraints are there. In addition to constraints, I am adding one more constraint, that is 3x1 minus 2x2 greater than equal to 16. See here, minimization problem we are going to include here. Maximization as well as minimization problem is included. So the next one is non-negativity x1 comma x2 greater than equal to 0. Okay, so this problem, while we are solving this problem, please listen very carefully. Okay, the next problem number 7, maximize z is equal to 3x plus 2y subject to constraint x plus 2y less than or equal to 10 and 3x plus y less than or equal to 15. These are the two constraints. Then non-negativity x comma y greater than or equal to 0. Okay, the problem number 7. Then problem number 8, maximize z is equals to 3x plus 4y subject to constraints x plus y less than or equal to 4. Okay, then non-negativity here x greater than or equal to 0 comma y greater than or equal to 0. This is the problem number 8. Okay, then problem number 9, maximize z is equals to 5x plus 3y subject to constant 3x plus 5y less than or equal to 15, 5x plus 2y less than or equal to 10. Okay, non-negativity x greater than or equal to 0, y greater than or equal to 0. So these are the 9 problems are there. You have to practice these 9 problems compulsory. Okay, so here, see, first problem already we solved and we kept in the YouTube channel. The second problem, according to the first problem, you practice. Third problem also you practice. Fourth problem, fifth problem. Then sixth problem also you have to practice. So here, see, today we are discussing, these are the some homework problems. Then tomorrow onwards, what we are going to do, we'll solve on this problem, the second problem. Then the next day, this problem. The next day, this problem, this problem, this problem. So in this way, we are solving each and every problem. So after completion of maximization graphical method, we are going to do the problems in minimization problem. So at this, we are going to close today. So my dear subscribers, please watch my video and promote my channel. And I want more subscribers. So kindly subscribe to our channel. Thank you very much. Have a nice day.